Right, here we go. Now we are getting cracking on the content of the rock cycle, and that's what I want to focus on today, is the fact that it is a cycle. So the word cycle means that it goes round and round, and in this case what's going round and round are the different rock types. So one rock type basically can form any other rock type, and that's what we're going to explore today. So let's get rid of me. Okay, this is the extract from the syllabus. So this is what you have to learn about as part of the rock cycle. So rocks are continually formed, modified and destroyed and reconstituted. That just means remade as part of the rock cycle. They're formed and modified by endogenic forces. Do you remember what that means? Endogenic forces are basically the forces that happen internally to Earth. So the movement of the plates, volcanic activity, and that kind of stuff. They are destroyed by exogenic forces. So exogenic forces is anything that happens above the surface of the Earth. So that would be like weathering and erosion. So they're destroyed by exogenic forces of erosion on exposure to weather and climate. So remember, erosion is just the breakdown of rocks. They are reconstituted, so they're remade by the deposition of sediments. Now, as usual, that's a bit of a mouthful, so we will convert that into plain English and hopefully it'll make a bit more sense. So what they're trying to say is rocks are constantly being made, so they're being formed, they're being changed all the time, they're being broken down, and they're being recycled, and this all happens as part of a cycle called the rock cycle. They are made and changed by internal forces, so that's the endogenic forces. And these are forces that are happening or that have their origins beneath the surface of the Earth, so within the crust. They are broken down and transported by the agents of erosion. So this would represent the exogenic forces. So wind, sea, rivers and ice. These break down the rock into smaller sediments, and these occur above the surface of the Earth. And then they are recycled because sediments are deposited. So if you look at this, so first of all, they're made by the internal forces. They're then changed and broken down. And when they're broken down, they produce sediments. Those sediments eventually get deposited, and those deposits will then form new rocks. Okay, so we're going to try follow that through. But before we do, I want you to put this table. Now, I know you don't have the booklets yet, but what I'm going to suggest you do is that you just get a copybook or a refill page, and anything that we do to go into the booklets that you write on that, and then you transfer them all in when I do give you the booklets. So this needs to go on page 3, and hopefully you remember the 3 categories of rock and the rock types, and this will just be a trip down memory lane. So first of all, the categories: igneous, sedimentary and metamorphic. So the igneous rocks, you think the word igneous is to do with heat, to ignite something. Okay, they're the rocks that are formed by magma and lava cooling and hardening. And you already know quite a bit about igneous rocks. Sedimentary rocks then, the clues in the word, they're made from sediments. So these are the rocks that are made from the deposits of other broken down rocks. Metamorphic rocks, so if you morph something, you change it. So metamorphic rocks are other rock types that have been changed. So once you know the categories, we have to then look in detail at the rocks within those categories. So for igneous rocks, the main rocks we're going to focus on are granite and basalt. For sedimentary rocks, it's very late. For sedimentary rocks, we're going to be looking at limestone, sandstone, shale and gypsum. I feel like I'm missing something there. And you already know quite a bit about limestone and sandstone and how they formed in Ireland from Munster Ridge and Valley. And then for metamorphic rocks, we're going to be looking at marble, quartzite, slate and schist. And quartzite and schist should be familiar to you because of the batholith. So do you remember we said at the batholith there was sandstone, and that got changed to quartzite, and there was shale, and that got changed to schist. Alright, so this table needs to go on page 3. This is really, 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 really important that you know the categories and you know the rock types. It comes up in the short questions all the time. And it's one that people get quite confused about, so very important that you know this table. Right, let's get stuck into the good stuff. So, this is showing you the rock cycle. Now, I always think it's easiest to start with the igneous rocks, which are over here, okay? So don't mind all the writing, I'm going to go through it with you. So we have magma. If magma cools beneath the surface, it's going to form granite, okay? If magma is extruded or explodes out at the surface, it's going to cool and harden quicker and it's going to form basalt. Okay, sometimes the magma will be exposed at the surface because all of this might be weathered and eroded away, and the basalt is already at the surface. So what happens is then that rocks at the surface are worn away by weathering and erosion, and they're then transported by rivers and by the wind. So the rivers flowing down to the sea, and the wind will also blow it into the sea. So what's happening here with these layers is that you've got sediments building up, and these sediments might be broken down rocks from the surface. These sediments can also be the remains of dead sea creatures, so ancient fish life, sea snails, shells, crabs, etc. And as those sediments build up at the bottom of oceans, sometimes in the bottom of lakes, the pressure from the layers on top will make them form into sedimentary rocks. So those sedimentary rocks have been formed by things that already exist, either ancient sea life or particles from other rock types. Now, we have igneous rocks, so granite and basalt, and we have our sedimentary rocks, limestone and sandstone. And sometimes then what happens is that if those rocks experience heat and pressure, now where might they experience heat and pressure? If you think about it. If you think about a subduction zone and sedimentary rock is subducted, isn't it going to experience heat? And that might change it. They might also experience heat and pressure because you might have magma flowing up or intruding into the surface and changing those rocks. So sedimentary rocks or igneous rocks might experience heat or pressure, this then changes them into metamorphic rocks. Okay, now I'm going to go over this using a number of diagrams, so sorry if I'm repeating myself over and over, but this can take a little while to get. Right, let's have a look at it here, and again I'm going to start with igneous rocks. So here we have the igneous rocks. Crystallization just means it's solidifying, it's becoming solid and turning into a rock. So the igneous rock is formed granite beneath the surface, and here we have basalt on the surface. The rocks on the surface are weathered, okay, so they're broken down and then they're transported, and you can see the river is bringing them there and some wind might be blowing them in, and those broken down rocks are deposited as sediments. More and more sediments are deposited and they then become sedimentary rocks. Now, either the igneous or the sedimentary rocks might undergo heat and pressure, and another form of pressure that can happen is at convergent plate boundaries where there's deformation. So that's just the topic that we finished. So if you have rocks being compressed and squeezed together, then that can also change them into metamorphic rocks. Right, let's have a look at this another way. So this is the whoopsie-daisies. This is the image that's in your booklet. And again, let's go to the igneous rocks. So here we have an intrusive igneous rock, which is granite, an extrusive igneous rock. Rock can be uplifted so that they appear on the surface. Weathering will break them down. Transport will bring the sediments into the sea, where they form sedimentary rocks. If those sedimentary rocks experience heat or squashing, then they become metamorphic rocks. If the igneous rocks experience heat, then they can also become metamorphic rocks. So basically, any rock type can become a metamorphic rock if it experiences heat and pressure, or heat, or just heat or pressure, okay? Sedimentary rocks can be made from any other rock type once those sediments are deposited into the sea. Now, sedimentary rocks could also become igneous rocks. So if you melt sedimentary rocks, then they're going to turn to magma and they can become igneous rocks. Metamorphic rocks can also become igneous rocks. So if that metamorphic rock gets melted completely into molten magma, then that might form an igneous rock. So any rock type can become another rock type. Not just amazing. Rocks are just so adaptable. Right, here's another one that's in your booklet. Igneous rock. Weathering erosion can turn it into sedimentary rock. Heat and pressure could turn it into a metamorphic rock. So this shows you how igneous rocks can become sedimentary rocks and how igneous rocks can become metamorphic rocks. Okay, let's take sedimentary rocks. So if sedimentary rocks are weathered and eroded, then they can form more sedimentary rocks. If sedimentary rocks experience heat and pressure, they can become metamorphic rocks. Or there could be another arrow here in that if sedimentary rocks are melted, they could become igneous rocks. Metamorphic rocks. If metamorphic rocks are weathered and eroded, guess what? They can become sedimentary rocks. If metamorphic rocks are melted to become magma, then they can become igneous rocks. I think out of all of the diagrams, this is probably the simplest to understand. Okay, so here we have some endogenic forces, just to refer back to what we said at the start. So melting and heat and pressure, they're forces that come from beneath the crust. And we also have exogenic forces, which are the forces on the surface of the earth, which would be weathering and erosion. Right, what's in store next? I think there's a video clip. Now, this is a bit ancient, but it is kind of useful. So yeah, let's watch it together.
Earth's crust is made up of a wide variety of rocks. On the coasts of England, for example, cliffs made of calcareous rock rise from the sea, while most of Japan is composed of volcanic rock. Rocks may appear to never change, but they are constantly evolving. Weathered by erosion, they crumble into small particles that are transported to the ocean floor. They are deposited as sediments, which become compacted and gradually form sedimentary rock. Slate and chalk are both sedimentary rocks. The sedimentary layers slowly sink into the crust. As the rocks sink deeper, the pressure and temperature increase and the rocks undergo metamorphoses. They are then called metamorphic rocks. Limestone, for example, is transformed into a colorful metamorphic rock, marble. The natural movements of Earth's crust can thrust sedimentary and metamorphic layers toward the surface, or push them deeper into the mantle. The extremely high temperatures in the mantle liquefy rock and transform it into magma. The slow-moving magma is sometimes pushed up toward the surface, notably during volcanic eruptions. As it cools, the magma solidifies in the form of magmatic rocks, such as basalt. So, the rocks of Earth's crust are constantly being transformed as part of a geological cycle that lasts millions of years.
Okay, this one's a bit more fun.
Bill Nye the Science Guy. Brought to you by rocks.
Did you ever stop to think that the whole world is covered with rocks? And every rock used to be different. When you're looking at a rock, you're looking at history.
Careful.
See, all the rocks in the world used to be melted rocks, what we call molten rocks. Molten. Like this molten rock in here. And do you see the bubble on top? It's from the heat. It's just like the rocks that come out of volcanoes. Rocks like this, rocks like this, rocks like these. See these pits They were formed by bubbles and liquid rock that came out of a volcano. Now sometimes the rock from volcanoes will come up onto the Earth's surface. Now when these rocks get on the Earth's surface, they push other rocks down. It pushes down on the layers below. Push the old rocks down. Push them down, and they'll squeeze together and swirl around. And when they blend together, they form a new type of rock, like the minerals that are swirled together in this piece of marble. Anyway, wind and rain moving over the Earth's surface break rock down into sand. And sometimes enough water will flow through the dust and sand, mix them together, push it around, and it'll dry out again and turn back into rock like these. Good thing I have my safety glasses on. Now this process, where rocks are formed, broken down, and reforming as they come out of the molten earth and turn back into dust, into rocks again, has been going on since the world was formed. Billions of years ago. Rocks! Rocks!
Rocks are formed in different ways. All the material in this sandstone once belonged to other rocks. That rocks!
Scientists like to think of 3 types of rock. Now the first type you might call igneous rock. Igneous rock. Now, igneous comes from the word for fire. You know how you ignite the candle and you have igneous rocks? You know, igneous, ignite, that's from the word for fire. So see how the candle wax drips down the outside of the candle? Well, igneous rocks are often formed when hot lava drips down the outsides of volcanoes, and it cools to form rocks like this granite. See? The next type of rock we call sedimentary rock. Now, sediment, that's silt, mud, goop in rivers. So if you have a river and it's washing sand, mud, or silt, sediment, downstream, well, eventually the river may dry up or drain away, leaving the sediment, the sand, silt, or mud. Now this sand would be heavy. It crushes down on itself, like this, squeezing itself together. Till eventually, after the water is completely drained away, after a few thousand years, you end up with a rock like this one. See the layers? Sedimentary rock often has layers in it because that's the way sand washes downstream in a river. Now the last type of rock is sort of a combination of the other two. We call it metamorphic rock. Now metamorphic means it's changed, it's metamorphosized. So if you look at this is rock that was once sand, but it's been smushed together by huge pressures under very high heat, pressure and heat, smashing the rock till it's just crushed flat like this. See, heat and pressure formed another rock.
Okay, enough of Bill. Right, we are not going to... Okay, that's just the course content, so we're not going to move on to that. So what I want you to do is, in your booklets, which are going to be, I'm going to put up as a PDF, you know. Hang on, I'll just find the page. Bear with me. Okay, so this is page 4 in the booklets. So I'm just going to read through this because there's quite a lot in here. So the rock cycle is the process by which rocks are changed, destroyed, and remade by endogenic, their internal, and exogenic, external forces. The 3 main endogenic forces are folding, faulting, and volcanism. Volcanism means volcanic activity, so anything that allows magma to rise to the surface. And these all happen at plate boundaries. The main exogenic forces which impact on rocks include weathering and erosion, compaction, that's just squeezing together, and cementation. Okay, so if you see the word cement in there, and cement means to stick something together. So all rocks fall into one of 3 categories: igneous, metamorphic, or sedimentary. Each of these rock types are related to each other and they're continually being changed from one type to another. So that's what I said, like sedimentary can become metamorphic, metamorphic can become igneous, etc. When discussing the rock cycle, always begin with the formation of igneous rocks. Now that's not like a rule of the universe, it's just easier to start that way. So igneous rocks are formed by the injection of molten magma into the crust. So just magma moving into the crust. The magma will either cool to form rocks or will erupt at the surface to form volcanoes. Igneous rocks are formed by a process called crystallization, and we will be coming back to that in detail. Rocks at the surface are weathered and eroded to create sediments. Wind and water will transport these sediments, and eventually these sediments are deposited underwater in layers and will form sedimentary rocks when they become compacted, so squeezed together, and cemented, stuck together. Sedimentary rocks are formed by a process called lithification, and again we will be coming back to that. Igneous and sedimentary rocks can be subjected to great heat and pressure that causes them to change into metamorphic rocks. The formation of igneous, sedimentary and metamorphic rocks is dependent on and part of the plate tectonics process. Weathering and erosion can occur after uplift caused by continental collision. So this means that if you've got a rock beneath the surface, like granite, if two continental plates collide, that rock can be pushed upwards and then it's found at the surface, and then it can be weathered and eroded. Metamorphic igneous and sedimentary rocks may be carried down into subduction zones. So this is if there's oceanic continental convergence or oceanic oceanic convergence. If that happens, they can be metamorphosed, so they're changed by the heat, and then they're re-injected into the crust as igneous rocks. So this is just basically saying that any rock category, if it's melted, becomes magma and then can form igneous rocks. In this way, the tectonic rock cycle completes a circle. The circle of life. Okay, now I'm embarrassing myself. Sediments and rocks have often been recycled a number of times in geological history. It is possible that minerals that are resistant to erosion, for example quartz, have survived recycling several times. Right, then we have the two diagrams that I went through earlier. And then, why three diagrams? Oh yeah, sorry. Then these are the questions that I want to that I want you to answer, and I will put this up as an assignment. So you use the diagrams to answer these. All right. So let me give you an example. Okay. So what processes change sedimentary rock to metamorphic rock? So how does sedimentary become metamorphic? So let's just start here. So here's sedimentary rock. How does it become metamorphic rock? It becomes metamorphic rock because of deep burial, when it's heated and when it's squashed, right? Then down here, how does sedimentary rock become metamorphic rock? Through heat and pressure. Does that make sense? So you've got to use the diagrams, all right, and follow the arrows to answer all of these questions. I'll do one more for you. Let's do this one. How is sediment converted to sedimentary rocks? So let's have a look at the diagrams. So here is sediments. That's not a great one. How is it converted to sedimentary rock? Well, the word burial there would help you. Here is the sediment. How is that converted to sedimentary rock? And here it says compaction and cementation. Okay, so between both of those diagrams, and also by possibly using these notes here, you should be able to answer these questions that I'm going to put up as an assignment. Ladies, this is really, really important, this introduction. Let me put myself back on. Sorry, I didn't mean for this to go on for so long. Okay, this is really, really important that you get this, because if we move on and you haven't understood the rock cycle and the basics of the processes, then you're going to struggle. So I know now I'm on 23 minutes and that's a bit heavy of a Friday, but it's really important. So please, I know you're probably zoned out at parts, but please maybe go through this a couple of times and make sure that you are comfortable with the ideas in it, the concepts. I will put up the PDF of the rocks booklet so you can refer to that, and I'll put the questions online, and you're more than willing to come and collect the booklet from me over the weekend if you so wish. I have no problem with that. Just please give me some warning. And yeah, hopefully Monday week you'll be back to join me in the building. All right, ladies, have a nice weekend, and I'll chat to you soon.